sense. And again, these questions are going to be familiar because I'm just going to go through and change these numbers, and this will be what's on the test. Now, the first question is pretty straightforward. So the question says something about rainy days. The TV weatherman says there's a 30% of chance of rain tomorrow. Explain what this means. So if you look in the back of the book, it says if there was 30% chance of rain tomorrow, based on previous data, similar days, it is rained 30% of the time. Now, I think this was kind of interesting. I'd love to know if you kind of agree or disagree. This is actually kind of oversimplifying this answer. There's a lot more science that goes into this question, but it does get you thinking about what probability is used for and also what it means. So I think a lot of times people say the term 30% chance, and they're not exactly sure what that means. All right, next question, 5.2. I think this one's an important one for me to kind of talk through if you didn't understand what it said at the back of the book. So this question is a simulation setup, and they want to know, can you design a simulation? So the question says 15% of people stopped, don't have their seatbelt on. So what 15% means is that if we stopped 100 people, we'd expect 15 of them to not have their seatbelt on. So they're saying in our simulation, what would we expect if we only stopped 10 people? And you can kind of see mathematically, we would expect 1.5 people in 10 to not have their seatbelt on. So they're asking in the question, can we simulate this outcome? And the answer would be yes. And there'd be a lot of ways to do that, but they want to see if we can simulate it with a random number table. And I'm going to walk you through that in case you've forgotten. So in the design, we would have to tell them that there's 100 numbers between the number 00 and the number 99. So that might take a little bit of thinking, but there's 99 numbers between 1 and 99, and then we're actually going to count 00 as a number. And this is a really good way to take 100 numbers and do a simulation. So we're expecting that 15 of the numbers, and we're going to designate those as 00 to 14, would be as if I'm stopping someone and I notice, ooh, you don't have your seatbelt on. And then if I come across the number 15 to 99, I assume it's these other 85 people that are wearing their seatbelts, and they've asked us to carry out the simulation. So I've described our design, which is also described on the answer key, and then they said carry them out and copy the numbers down on your paper. So if you want to pause and put these numbers on your paper, and then we can do this simulation together. So since every one in my simulation has a 2-digit number, I'm going to hop along. So I got the number 29. They're wearing their seatbelt. The number 9, not wearing their seatbelt. Or excuse me, number 7, 07, not wearing a seatbelt because that's a number between 0 and 14. The number 71, wearing a seatbelt. 48 wearing, 63 wearing, 61 wearing, 68 wearing, 34 wearing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I just went through a simulation of 10 cars, and these are representing my cars, and I only came across one person on a seatbelt. So that's pretty consistent. But they actually asked me to look for something very specific. What would I expect if I stopped 2 cars in a row? So right now, I have to say, nope, I didn't get that. Simulation 1. Only one without seatbelt and didn't get consecutive, which is what I'm actually looking for. Consecutive drivers without seatbelt. Okay, so we're going to keep going. Excuse me, you couldn't read that. I'll just scoot that up. So simulation 1, only one person was without a seatbelt and we didn't get 2 drivers in a row. So now we're gonna do it again. I'm gonna do another simulation. I'm gonna pretend I'm pulling over 10 cars and we will see, excuse me. So seatbelt, 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 no seatbelt. So this car 10 didn't have a seatbelt on because the number 10 is between this range. 25, seatbelt, seatbelt, no seatbelt. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, we got 2 in a row. So on our second simulation, we actually did get, I don't know if you were expecting that or not, in the second simulation, 1, 2, 3, 4, we got 4 people without a seatbelt. That's way more than we probably expected. And we also ended up getting 2 consecutive. We did get 2 consecutive drivers without a seatbelt. Now notice, I'm not looking for or skipping any redundant things because each one of these are just simulating another driver, another driver, another driver. Okay, now let's do it again. Last simulation, 10 more cars. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so in this simulation, I believe I just have this one, 13. Simulation 3, only one without seatbelt. I didn't get consecutive drivers. Without a seatbelt. Okay. Now our next question is a rolling of the dice. So let's see if we can figure this out. It says, we rolled 2 dice, a dice A and a dice B, and they're weird. And I actually have dice like this. So they have little stickers on them, and I can make the faces whatever number I want. So they went in and made dice A, a 2, 2, 2, 2, and a 6 and a 6. They made dice B, a 1, a 1, a 1, a 5, a 5, and a 5. And they've asked us to build a probability model and figure out the difference between the 2 dice. Okay, so that's pretty easy. The difference, I just have to make sure I'm subtracting in the direction they want me to. So they said take the outcome of dice A and then subtract dice B. So here in the simulation, I get a 2 and a 1. So 2 minus 1 would be 1. Here in the simulation, I roll a 2 and a 1, and I get a 1. 2 minus 1. 2 minus 5, I'd get a -3. Okay. So here, this would simulate, I got a 2 from A and 1 from B. So that would be 1. And then same outcome, 2 minus 5. Six minus 1 is 5. 6 minus 5 is 1. All right, so now if I'm going to build a probability model, you may have looked at the answer in the back of the book and still been confused. So I'm happy to kind of do a little bit more explaining here. So we want to set up the difference. And so the difference here, it doesn't look like I have one. It looks like I only have 3 possibilities. Either I'm going to get a difference of 5, of 1, or of -3. Okay, And those were the only differences I could get. Now it looks like most of the time I'm expecting to get a difference of 1. So I'm really just counting up these blocks. So it looks like I got 4 times 3 is 12, and 2 times 3 is 6. So 12 plus 6 would give me 18 out of a total of 36 possible outcomes. Okay, then I'm gonna get a 1. And then here it looks like 1, 2, 3, 4, 5, 6 of the outcomes out of 36, I get a 5. And 12 of the outcomes out of 36, I get a -3. And so that's the difference I'm expecting. And that's exactly what a probability model is. Okay. Now it says, explain which one would be more likely to roll higher. So which one would I expect to be higher? Well, if A is higher and I subtract B, I'll get a positive number. Notice I did get a positive number most of the time. So all of these are positive numbers. In the table, I could think of it as all of these being positive numbers. So in a way, I could think of it as the probability of getting positive or expecting, I expect die A to be higher. And the reason why is the probability of it being positive is these added together. So that'd be 24 out of 36, which is a majority of the time. Thanks for joining us. Check out the next video.